Yeah, it looks like we're kind of leveling off here. So I'm going to go ahead and get started because we have to have this wrapped up by 10 after. So hopefully right now you can see our studio on your screen. We're going to run through some code, and we're also, before we do that, going to run through building a data extract with the IPUMS extract website. But what I would like to do maybe is I've got the code we're going to look at broken out into these chunks in my R Markdown document. And I thought that a good way to do this might be like after I run a chunk, take maybe one question through the chat if anybody has one. Otherwise, we'll just kind of keep on moving. And Nina and a pair of our graduate research assistants are going to be monitoring the chat so that Nina can read the question aloud to me, and then I'll answer it as best I can in the in the time we have. But I just want to emphasize this. If we run out of time for your question, we're going to write down all the questions that were asked here and answer them in a blog post in a couple of weeks. And I'll share the link for that coming up. Does that sound good to you, Nina?
Yeah, that sounds good. I don't think there's anything else.
Okay, so let's move over to the data extract system, and I'm going to switch windows here. One sec. Okay. So what we would like to do, assuming that we're registered IPUMS PMA users, is just get a quick extract with only the Kenya 2019 sample in it. And I'm just going to select the contraceptive calendar variable. So I'm going to come up here to browse and select data. And if it's the first time that you've opened this site, you'll be prompted to choose a unit of analysis first. Or if you have been on here before, it might have remembered the unit of analysis you were looking at last. So it's important to switch over to the family planning person level. We have the family planning service delivery point unit of analysis right before that, which is also important to find. But those are healthcare facilities. We want individuals. And I like to select my sample first. So I will come down here and find the Kenya 2019 sample. And then below this, the person level unit of analysis contains, by default, just the female respondents from the household screening survey. But if you wanted information about all household members, that's possible here. I'm also going to filter out people who didn't complete the survey. So we're just going to have female respondents in our data extract. So I'll click submit. And then to find the contraceptive calendar data, you want to look in the family planning topics, and it's the last option down here. So the only variable that appears, because I've already selected the Kenya sample, is the Kenya specific contraceptive calendar. If I hadn't specified a sample prior to this, you would see different contraceptive calendar variables for each of the countries where they're available. But this makes it easy. So I'm just going to click the plus button here, which adds it to my shopping cart. So I'll click view cart, and you see that a number of variables are pre-selected. So my extract is going to contain all of the pre-selected variables plus the whatever I selected. So the calendar is at the bottom. So I'm going to click create data extract. And what's important for our users is that we're going to select a specific data format. We want the fixed width text, or DAT format for R. If you're a Stata user, you'd be using this one. We have SPSS, SAS, and CSV files available as well. It'll ask you again, do you want to only have female respondents? And yes, I do. So I'll click submit. You can put a note into your profile describing your extract so you can keep them organized. Call this PAA example and hit submit extract. So you can see the IPUMS extract system keeps track of all of the extracts that you've made with your user account. And it takes a little bit for this to process. In fact, I think mine might be done already. Right, so what you want is to download this DAT file. And then because we have so much metadata, we keep it in a separate XML file. It's right here. It's the DDI codebook. So you would normally want to save that link as something. So you'll have two files to download. One's the actual data file, and the other is the metadata that contains, for example, variable labels. So I'm going to pop back over to our studio because I've actually already downloaded both of those files and put them in the working directory I have for my RStudio project. But before I get into that, I want to pause real quick. Nina, are there any general questions just about the extract system or how to find the calendar variable?
So far, no questions, but I'm just going to pop a link in the chat to our blog post that has a lot more detail and walks through step by step on how to download and access the PMA data from using the IPUMS extraction tool.
Awesome. Okay. Yeah, I see it's already been 9 minutes, so I'm going to kind of move through things a bit quicker. So normally, I think what you would do is set your working directory in R to wherever you downloaded those files. I've already grabbed them and put them in an RStudio project folder. So when you have an RStudio project, you get a little file that looks like this. Here's my script. And then these are the two files that I downloaded.
Matt, just so you know, we're still looking at the extraction website, not your markdown file.
That would be a tragedy. Okay, look good? Perfect. So in my files pane in RStudio, you can see the two files that I downloaded as well as a script. So what we're going to do in the exercise today is use 4 packages. IPUMS R is going to contain the function we need to open the data. We're going to use tidyverse to grab a bunch of functions that we're going to use for data cleaning. The survival package contains the function we need for survival analysis. Makes sense. And then lastly, I'm going to use a package called ggfortify, which tells base R how to use that auto plot function that we looked at in the slides to build a survival curve. I'm also just going to set the default for our data frame viewing to 20 rows, just so that you can see everything in this tiny window that I have. I'm going to minimize this. Okay, so like I said, IPUMS R contains the function that you need to open those two files and make them into a data set. So it's read IPUMS micro. I'm going to run that right now. You get a little message saying, please obey our terms. And then when you open the data, it looks like this. You see the 17 variables that we have in the columns, and then each row represents one female respondent. So I'm going to do something that I don't recommend doing when you're actually conducting analysis. But you see here that we've got a person ID already. And the problem that I have with this is it starts with a prefix that looks the same for every person. And it's not ideal for this exercise. So I'm going to make a variable called ID that just has the row index for each person, just so I can keep track of people while we're together today. So when I do that, I can select the variable ID and the variable calendar KE. So we're just focusing our attention on those two things. You can see here the calendar KE variable is a string with commas in it. And part of the challenge that we have is that some individuals were interviewed in December, so they have 36 values, but some were interviewed in November, the month before, so their December their last month is empty right here. So they've got this trailing comma, leading comma issue that Devin mentioned. When we separate this out, we'll have 36 columns, one for each month. But for people like the second person, we want the first column for them to be blank. So we can achieve this with a function from the package tidier. And tidier is one of several packages that gets loaded when you load the tidyverse package at the top. So I'm going to split this column into 36 columns that each start with the letters CALKE, but have a suffix number attached to them. And fill left tells us that for this person right here, we want their empty column to be on the left-hand side. So here's what that looks like when we run it. You can see like there are quotes around just this column because of these empty strings. Basically, it's preserving that symbolically. Each one of these, though, is a character type of variable. Okay, any questions so far, Nina?
So far, no questions, but if anyone is confused by any steps of this, please just feel free to drop your questions in the chat and we will definitely do our best to answer them. Or if they're more involved and require some coding explanations, that's sort of great for us to explain on the blog, because if you have questions, other people do too. Yeah, absolutely. Okay, I'm going to now pivot these into the long format that we discussed in the full session. And I'm going to, again, change the default printing just so that when we take 36 columns and move them sideways, you can see at least all of one person's records. So pivot longer is also from the tidier package. We're going to say we want to take any column that starts with the letters CALKE and pivot it into a new column called FP for family planning. This little part right here is, I think, the trickiest part of this function. The bit in parentheses is what we're going to insert into a parallel column called month. So basically we're saying anything you see after the letters KE is going to be the month index number. So I want to pass that to a new column called month. And that doesn't make a lot of sense when I explain it out loud, but here's what it does. So it takes the 36 out of cal KE 36 and puts it under month. And then it takes the value for the first person in month 36 and puts it in a column called FP. So this is called a glue specification. And I don't know, it took me a lot of practice to learn how to use it efficiently. But we've got several posts on the blog at this point that demonstrate how to do this in different contexts. So hopefully that's useful. So now you can see. Also, Matt, just quickly to interrupt, I just wanted to maybe mention, if you look at the number of observations at the very top where it says a Tibble, there's 343,000 rows now. So you can see it's a much longer data set than it was before. Yes, that is what we mean by long format. Very, very long. So you can see now the first person, they occupy 36 rows. This is the first month chronologically, so their oldest month. The 36th month is the most recent month. For that second person who had a missing value in the 36th month, we see an empty character string here. So that's the main part of what I wanted to focus on. I know we don't have a lot of time left to make the survival curves. So I'm just going to run through it very, very quickly. But again, all of this code is already posted on the website. So let's just do something quickly here to apply labels where we had those values, so they're a bit easier to work with. I'm going to change the empty string to NA and actually use labels that we can read without having to remember the arcane coding scheme. So now you can see more clearly, and we'll begin our survival analysis. Yeah, we're very short on time, unfortunately. So I'm going to really whip through this.
what we want to do is identify, for example, the survival rate of using the contraceptive pill. To do that, I first need to identify, I guess, just women who were using the pill in the very first month, and we'll drop everybody else. So we're just going to be looking at people who started out using the pill. So filter all people who weren't using the pill out. Now in R, we have to be pretty explicit, unfortunately, about finding the last month that an individual was using the pill. So I'm going to do that here. So I create a variable called last month that indicates if it was the last time they were using the pill. So it looks like this. Then we're going to identify, like, if it's the last month for an individual using the pill, is it because they stopped using the pill at that point, or is it because they're one of those people who don't have a 36th month? That's a right-censored case if you're familiar with survival analysis. I'm going to do that here. Will indicate if they actually ceased as a logical variable that we're going to call ceased. Okay. Finally, we can filter down just to the last month so that we're back to just one record per person again. And this is where we'll use the survival package to fit a survival analysis. So we'll just do a little summary here. This shows us one row per month. It shows us how many people dropped out and the percentage of people who remain. So you can see that we began with four people who I guess were had maybe a missing value, and we increased to 6 dropouts total by the time the second month came along. So we can plot this with auto plot now, and I'll just apply some labels. This looks a little bit, I guess, different than what we saw in the full presentation because it's got a confidence interval on either side of the plot. So that's a super quick and dirty rundown. It's already time for us to go. I'm sorry about that. But if you have any questions about this code, please reach out to me or Nina afterward. I think our contact information will be in the, oh.
It looks like we have 5 more minutes, Matt. So if you wanted to back up a little.
Yeah.
Or if anybody has any questions, feel free to drop them in.
Yeah. Any questions so far?
Just one question. I don't know, Matt, if you have availability after the whole webinar ends to field a couple of questions, but there is one participant, Miriam, who has some questions after the webinar.
Always happy to talk to Miriam. Okay. All right, that sounds great. So while we have the time, I wanted to point out basically, something you've been seeing in the code so far are these pipes. And I have basically separated all the different steps for the pills example, just so that we can kind of talk about them sequentially. When we switched to looking at survival of implant use, I just piped all of the functions together. So that's a really cool feature. If you're using the tidyverse, you automatically get access to this pipe and you can kind of make your code a little bit more concise. So this is what it looks like when you run the implants use curves, and we can see the same summary and a different plot for implants. So yes, it would probably be ideal if we could put these two things on the same plot, but if you kind of want to compare, it seems like there is a steeper drop-off in use of the pill compared to contraceptive implants. Something else that we wanted to do was make a The graph that you saw at the very beginning of Devon's presentation, which includes a survival rate of all methods put together. We have a bit of code in here that does that as well. I'm afraid we don't have a lot of time to talk about it, but we can at least look at the comparison. So I think I'm going to stop there because we only have 2 minutes left. But I wanted to thank everybody for coming today. I know this was a lot really fast. But yeah, such is the nature of these interactive coding seminars sometimes. So,
Matt, I just wanted to flag, one question. It looks like a couple questions are coming in, but one is about how you would handle observations where women start, stop, and later start contraception or are switching between methods.
Yeah, for this example, we have not allowed re-entry into the pool just because we wanted to keep it kind of simple. And there are some survival analysis methods that don't handle re-entry particularly well. Survival analysis is not, by design, it's often used for in biomedical research and things. So this is kind of a strange use case, and we just wanted to keep it simple. Nina, did you have anything to add to that?
Yeah, I would add, I think that, so this code could very easily be extended to just, once you have it in a long format, any month you can sort of identify whether, the respondent is using a method. So then you're sort of tracking switching and things like that. And so I think to answer the question really depends more on your analytical tool. And so some survival methods might not be the most appropriate for those questions, but I do know there are survival extensions where you can have sort of multiple events or events can happen multiple times for the same person, and that there's extensions of sort of standard survival methods for those cases.
Yeah, great question. Was there a second question, Nina?
There is. It's just about sort of you're looking at cases that start in month 1, and how would you change the code to start in month 2 or 3 or later? And if that's something you can answer quickly, you can maybe go ahead, but if not, we'll definitely answer that one on the blog.
I think that off the cuff, I would guess that you could just use the filter function to change the initial month. So you just essentially drop that first month. Or if you had it for certain cases, you can use dplyr case when to build a sort of logical a case for which records to drop them from and which to keep the first month. So yeah. All right, everybody, I think we're going to head back to the full session, but thank you very much.
Just before we all leave again, I just put the link to the blog there, which definitely will have all the upcoming posts that will explain this, and also lots of other hands-on sort of coding vignettes and applications in R with the PMA data.
Excellent.